My name is Dr. Mike Murphy. I'm an assistant professor of computer science and information systems at Coastal Carolina University. In this lecture, I will introduce basic UML class diagrams. This introduction will be language independent and will focus on the diagrams themselves. I will cover language-specific uses of class diagrams in later lectures. UML class diagrams provide a graphical way to illustrate relationships between classes in an object-oriented system. They also provide a way to draw an abstract diagram of a class so that we can inspect features visually without having to resort to looking at code. Although class diagrams are a UML standard, in practice there are differences between the diagrams produced by different tools. Not all tools support all UML features. Some tools add extra features, and the final appearance of diagrams drawn by different tools varies. Certain UML tools are capable of round-trip engineering, which means they can draw UML class diagrams from existing code and generate program code from UML models. Generated code provides templates of classes that programmers can finish. The ability to perform round-trip engineering depends upon having a programming language the tool can parse, or upon having a UML class diagram model in a format the tool can use. The basic entity in a UML class diagram is a class. Classes are represented in the simplest case by boxes containing the class name. Here we have a sample class named Hello World, represented by a rather underwhelming box. In object-oriented designs, the data members of a class are often called fields. Class fields are listed in a UML diagram between two horizontal lines under the class name, inside the box representing the class. The first character in the field name gives the field's scope, a plus sign for public scope and a minus sign for private scope. There are other scopes, which are represented by other symbols, but remember that different implementation languages support different scopes. Different programming languages also use different type systems. In the pure case, UML class diagrams can be drawn to be language independent. In practice, however, most UML class diagrams have language-dependent semantics, which include the type system used in the target language. In this example, the Hello World class has one field, a private member named Message, which is of type message with a capital M. The capitalized message refers to another class, named Message, of which message with a lowercase m is an instance. Methods, or member functions in C++ speak, go below the class fields in the bottom section of a class box. These methods are functions that are members of the class, which can be called to operate on instances of objects. Static methods, or methods that can stand alone without having to be called from an instance of a class, are underlined. The same scoping and typing conventions are used for methods as are used for fields. As with fields, the exact semantics tend to vary from tool to tool, with each tool using a slightly different format. In this example, we have added 5 methods to our class, all of them public. We have setter and getter methods for the underlying message, setMessage and getMessage, respectively. The class also has a mechanism to display the messages using the speak method. 2 of the methods are special. The first of these is the Hello World method, which represents the class constructor. The second is the underlined main method, which is a static method that implements a main driver program for the object-oriented system. Relationships between classes in UML class diagrams are represented by lines connecting the classes together. These relationships fall into 2 general categories: generalization relationships, which show inheritance between classes, and association relationships, which show how instances of classes relate to each other. Each relationship in a class diagram can have multiplicity numbers assigned at one or both ends of the line connecting the classes. Multiplicities can consist of a single number, such as the number 1, or a range of numbers separated by 2 dots. If the range is unbounded, the second value after the dots is a star instead of a number. Multiplicity values specify how many instances of a class are involved in a relationship. As an example, if a relationship between classes foo and bar has a multiplicity of 1 on the foo side and 0 dot dot star, or just a single star by itself, on the bar side, that relationship specifies that for every single instance of foo, there can be 0 or more instances of bar in the relationship. As I mentioned before, one of the two categories of relationship in a UML class diagram is the generalization, which expresses the is-a relationship between classes. This relationship corresponds to inheritance in an object-oriented programming language. In this example, the simple message is a type of message. In other words, the simple message class is a child class of the message parent class. This relationship is drawn by connecting a line from the simple message class to the message class, with a hollow arrow at the message end pointing to the parent class. We leave off multiplicity on this type of relationship since generalizations are between classes themselves and not between instances of classes. The first type of association relationship that I will describe is the aggregation relationship. An aggregation is a weak type of has-a relationship between class instances, in which an instance of one class provides a collection of instances of other classes. It is important to note that aggregation relationships are considered weak has-a relationships because the instances that are collected by the collecting class can exist independently from the collecting class. In practice, this means that we create instances of various classes and then add those instances to the collection, typically with a dedicated method in the collector. For example, here we have a multi-message class that acts as a collection of message instances, as indicated by the relationship with the hollow diamond at the multi-message end. Multi-message provides a method, addMessage, to add an instance of a message to the collection. This instance is already created elsewhere in the code before the addMessage method is called to add it to the collection. If we want a class to contain instances of other classes without having to manage collections, we can use a composition relationship. A composition is a type of association that expresses a strong has-a relationship between classes. In a composition, a class instance contains one or more instances of another class, and those instances are created or destroyed by the containing class. It is important to understand this key distinction between an aggregation and a composition. With an aggregation, we create instances to add to the collection, then add them to the collection. With a composition, the instances are normally created in the class constructor for the composing class and destroyed by the destructor of the composing class. There are no methods to manage the collection of composed instances. Graphically, the composition relationship is represented by a filled diamond at the composing instance end of the relationship, as shown in this example. Here we have a double message composing instance that contains two instances of simple message. As shown by the multiplicity of the relationship, each instance of double message has exactly two simple message instances contained within it. These simple message instances will be created whenever an instance of the double message class is created, and both simple message instances will be destroyed with the double message.